Thermal pollution. Sources of thermal pollution.
Industrial processes. Discharge of heated water from power plants, steel mills, and chemical factories. Cooling processes in thermal and nuclear power stations.
Urban runoff, water from paved surfaces that has been heated by the sun. Deforestation reduces shade along waterways, increasing water temperatures. Heat islands.
Causes. Urbanization, concrete, asphalt and buildings absorb and retain heat. Lack of vegetation reduces natural cooling through evapotranspiration. Industrial activities release heat into the environment.
The consequences of urban heat islands are quite profound. Increased energy consumption for cooling, elevated emissions of pollutants and greenhouse gases, and negative impacts on human health such as heat stress and respiratory issues. Additionally, we see altered local climate patterns and reduced air quality.
Next, let's dive into the topic of marine pollution. When we talk about marine pollution, it's essential to understand its sources.
Oil spills are a major concern for our oceans. These spills can occur due to accidental releases from tankers, drilling rigs, and pipelines. Additionally, operational discharges from ships also contribute significantly to the problem.
Now, let's talk about land-based sources of marine pollution. Agricultural runoff, which includes pesticides and fertilizers, is a major contributor. Industrial discharges and sewage also play a significant role. And of course, let's not forget about plastic waste and other debris that end up in our oceans. Another crucial aspect to consider is atmospheric deposition. This involves airborne pollutants that eventually settle into the ocean, adding another layer to the complex issue of marine pollution. Impact of marine pollution.
Ecosystems. Destruction of coral reefs and marine habitats. Toxicity to marine life, leading to declines in populations.
Human health contaminated seafood can cause health issues. Beach and coastal water pollution affecting recreation and tourism.
Economic consequences. The impact on fisheries and tourism industries can be devastating, leading to significant financial losses. The costs of cleanup and mitigation efforts are often substantial, placing a heavy burden on local economies. Methods of abatement of marine pollution. There are several strategies that can be employed to reduce and manage marine pollution effectively. Prevention. Regulations and enforcement to control discharges are crucial in minimizing marine pollution. Proper waste management practices must be implemented to ensure that pollutants do not reach our oceans.
Skimming and absorbing oil spills, bioremediation, using microorganisms to degrade pollutants, mechanical removal of debris and plastics.
Education campaigns to reduce littering and promote sustainable practices. Coastal management. Integrated Coastal Zone Management, or ICZM, is a holistic approach to managing coastal resources and development. It balances environmental, economic, social, and cultural interests.
Protected areas involve establishing marine reserves and protected zones. They also focus on the restoration of degraded habitats.
Sustainable practices are all about promoting sustainable fishing and tourism. They include implementing measures to reduce coastal erosion and pollution. Radioactive pollution. Sources.
Nuclear power plants, routine operations and accidents, disposal of radioactive waste.
Medical and industrial sources of radioactive pollution are, well, quite significant. The use of radioactive materials in medical imaging, cancer treatment, and various industrial applications contributes to this type of pollution. Natural sources of radioactive pollution are also, quite prevalent. Radon gas, for instance, comes from the decay of uranium in the soil and can pose serious health risks.
Nuclear weapons testing has been a major source of radioactive pollution. Both atmospheric and underground tests have, unfortunately, released significant amounts of radiation into the environment.
Biological effects of ionizing radiations.
Cellular damage, DNA mutations, cell death and cancer, damage to tissues and organs. Acute radiation syndrome or ARS, nausea, vomiting, hair loss, skin burns, and potentially fatal. Long-term health effects due to radiation exposure can be quite severe. There's an increased risk of cancers and genetic mutations, which can affect not just the individual, but potentially future generations as well.
Radiation exposure and radiation standards are critical topics when discussing nuclear safety and public health. It's important to understand how exposure is measured and regulated to ensure safety.
Radiation exposure is measured in sieverts, or SV, which quantifies the biological effect of radiation. The sources of radiation exposure include background radiation, medical procedures, occupational exposure, and unfortunately, accidents. Each of these sources contributes to the overall radiation dose a person might receive over their lifetime. The International Commission on Radiological Protection, or ICRP, provides guidelines for radiation standards. These guidelines set limits for both occupational exposure and public exposure. National and international regulatory bodies enforce these standards to ensure safety.
Radiation protection is crucial for ensuring the safety of individuals and the environment from the harmful effects of radiation.
When it comes to minimizing radiation exposure, there are three key principles: time, distance, and shielding. First, minimizing exposure time reduces the dose of radiation one receives. Second, increasing the distance from radiation sources significantly lowers exposure levels. And lastly, using shielding materials like lead or concrete effectively blocks radiation, providing an essential layer of protection. Monitoring and control are crucial in managing radiation exposure. Personal dosimeters are used to monitor individual exposure levels, ensuring safety. Additionally, controlled access to high radiation areas helps minimize unnecessary exposure. Emergency preparedness is essential for nuclear safety. Comprehensive plans and protocols are in place to handle nuclear accidents effectively. These include evacuation and decontamination procedures to protect public health and the environment. Waste management is a critical aspect of dealing with radioactive materials. Safe disposal and storage of radioactive waste are paramount. Containment and isolation measures are implemented to prevent any environmental contamination.
Effective management and mitigation of pollution, whether thermal, marine, or radioactive, require comprehensive strategies, regulatory frameworks, technological solutions, and public awareness to protect both environmental and human health.